Welcome to our third in the series of lectures on Charles Darwin's book, The Origin of Species. In this lecture, I'm going to focus on Darwin's own life and experiences and how that leads him to the discovery of the theory of natural selection and common descent. Darwin is born in England, in Shropshire, in 1809. He's the son of Robert Darwin, a prominent investor and physician. Robert is the son of Erasmus Darwin, an extremely important natural historian and physician of the late 18th century, and one of the earliest people to ever promote a theory of evolution of his own. So evolution runs in Darwin's family. His mother is Susanna. Her maiden name is Wedgwood. She is the daughter of Josiah Wedgwood, the founder of the Wedgwood pottery firm. So, wealthy, educated, intellectual environment that he grows up in. He follows his grandfather, father, and brothers to medical school at Edinburgh in 1825, where he does not do particularly well and leaves without a degree in 1827. Transfers to Cambridge, where he struggles for several years, but does finally graduate with a BA. But he's pretty much doesn't know what to do with himself, and manages to, through some people he meets at Cambridge, where he does become fascinated by natural history and make some minor contributions of his own, to get the opportunity to travel as the naturalist on the Beagle. The Beagle is a Royal Navy warship and survey ship, commanded by James Fitzroy, and Darwin's job is as much to be a companion to Fitzroy as it is to be a naturalist, although I'm sure they had a lot in common. Fitzroy himself goes on to be a prominent scientist. He's the founder of the Royal Meteorological Society and one of the inventors of modern weather forecasting. So Darwin spends 5 years doing a double circumnavigation of the globe on the Beagle. And when he returns, he publishes his first book, The Voyage of the Beagle. Huge bestseller. Still a really fun read. This is the popular version. He also publishes a series of major scientific studies on geography, geology, biology, natural history, coral reefs. This seems to be when he first develops his interest in Cirripedia, that is, barnacles, and together it leads to him receiving the Royal Medal of the Royal Society in 1853. In this period, the Royal Medal would probably have been seen as the second most important scientific award in the world, just behind the Royal Society's Copley Medal. Both of these are still awarded. The Copley Medal is the oldest scientific award given continuously and is generally considered second in rank today to the Nobel Prize. Darwin gets the Copley Medal in 1868 to go with his Royal Medal. Most importantly, at that point he meets Thomas Huxley, the man who will come to be known as Darwin's Bulldog, his most aggressive public defender. Huxley had won the Royal Medal the year before. And it's Huxley who arranges in 1858 for the first public airing of Darwin's theory of evolution by natural selection. Huxley knew that Darwin had been working on this idea of natural selection for many years, but Darwin is a famously picky thinker. He really doesn't like to publish until he's sure that he has dotted his I's and crossed his T's. And Wallace, who is working out in the Far East, sends Huxley a copy of a paper where he introduces the notion of natural selection. And Huxley says, but Darwin's already working on this. And Darwin says, that's okay. And the two papers are read together rather than create a priority dispute. Darwin says, let's just introduce it together at the Linnaean Society, and they announce their independent discovery of the principle of natural selection. And about 15 months later, Darwin publishes The Origin of Species, and it literally sells out immediately. They printed 1,000 copies. They sold by noon. It could not be kept in the shops. It was a huge bestseller. And the most important part of this is that, of course, Darwin was already famous for the Beagle. And the Beagle voyages provide the core insights that lead Darwin to this solution of the problems that I mentioned at the end of the last lecture. How do you explain the variability in time and space with the functional fine-tuning of organisms? So this is basically the path of the Beagle. And the first thing I want you to notice is to look for the Galapagos and the Cape Verde Islands. They're basically in the same latitude. They're very, very similar. They're similar geographically, geologically, climatologically, and yet they are occupied by radically different kinds of animals. As we would expect today, right, the Cape Verde Islands are occupied mostly by variations on the flora and fauna of Africa. The Galapagos are occupied by variations on the flora and fauna of South America. Notice that, again, there's no knockdown argument in The Origin of Species. There's no place where Darwin says, aha, I have proved that special creation never happened. Right? No, what he does is he says things like, well, if special creation is what's going on, then we would expect that similar climatological, geological situations would be occupied by similar kinds of flora and fauna. And he says, that's not what we see. Why not? Why is it that being close, what you're close to, matters more than the local environment? Another way to see this, right? So this is not one of Darwin's insights, right? This is from Wallace. This is what drove Wallace's insight. So if you look at this map here, right, Sunda and Sahul, right, are basically modern Australia. Sahul is Australia, right? The Sahul is the gray and white together, right? It's a hypothetical ancient continent, right? And Sunda is the continent that you would have seen from the Indonesian islands, right? So Sumatra, Borneo, Java, at, say, the time of the last ice age, were not islands. They were mountains on a peninsula, on essentially an extension of the Malaysian peninsula. And so you've got these two. Then why then are there these big lines? So if you look, right, the so-called Wallace line is the line on one side of that line, you see Australian birds. On the other side of the line, you see Asian birds. Why? The short answer is land birds won't fly out of sight of land. And that's the gap. That's where there's a gap. But notice, right, they're very close together. There's no ecological reason why there should be a big shift there. And yet there is. So Darwin, Wallace have the ability to see what's going on in ways that many people before them did not. The other thing that Darwin gets to see, and that plays a huge role, is he gets to see and study carefully a lot of different oceanic islands. So these are oceanic islands, are islands that are isolated from the mainland. So the Galapagos, the Cape Verde are the two most famous. And as we mentioned, right, the first thing Darwin notices is that the flora and fauna of an area depends on geographical location as much as on the local ecology. That it's not inconsistent with special creation, but it's odd if you believe in special creation. The other thing he notices, and this is where the famous Galapagos finches come in, is that there are substantial variations in the populations over relatively short time scales. So one of the things Darwin notices is on different islands of the Galapagos, you have these finches, and they're very closely related. Right, they're clearly birds that have colonized the islands in various ways from the mainland and then spread through the islands. But you have this sort of funny situation where, for example, on islands where the plants happen to have hard shells on their seeds, you see finches with short beaks. That makes it easier for the finch to crack the shell on the seed. But on islands where you don't have hard shells, but you might have seeds that are harder to get to, you see finches with short beaks. How did that happen? How did this ancestral population become variable in a relatively short period of time? All right. And it leads him ultimately to being able to see this crucial role of this sort of biohistorical oddity, as I'm going to call it, right? This question of why does containment, that is, why does the fact that various classifications of animals or plants, but we're going to focus on animals, right, manifest temporally. That is, it's not just that mammals are tetrapods. So tetrapods are the class of vertebrates built on the four-limb model. Mammals are tetrapods, are vertebrates, are chordates. Chordates are any animal with a spinal column, which might or might not also involve a bony spine. But why do we find chordates before we find vertebrates, and vertebrates before tetrapods? So why do we have fish before we have tetrapods? So vertebrates before tetrapods, right? Why does containment manifest temporally in the fossil record? Well, Darwin says ultimately because it's the same thing. Containment, being of one of these larger containing kinds, is because you're descended from those earlier kinds. And so Darwin is teaching us to see these, what used to be seen as fixed objects and fixed classifications, as something which are dynamic and produced. And the most famous statement of this is the most famous paragraph in any scientific book. Many of you have probably seen this. It's reprinted in almost every basic biology text. The very last paragraph of The Origin of Species. I'm not going to read the whole thing here, but I want to point out a kind of pattern that arises. So notice here, right? So we start with contemplate a tangled bank. So that's a thing, right? But it's a thing which is alive. It's clothed with plants. It's got birds singing, insects flitting. It's a thing that is happening. And all of these things are dependent on each other. They have this complex interdependence. They are produced and producing at the same time. How? Well, most amazingly, by just a few simple laws, right? Growth with reproduction, inheritance, variability, natural selection. All of these things produce not just that tangled bank, but the view of life that Darwin wants us to have. So next lecture, we will begin to look at this problem of variation and how it arises. How do these laws produce the world we see around us?